Okay, so hey, train plants every day. So I'm working on a functional analysis problem. It was one I worked on for a while before. Generally, I have the first consensus, which is really all I need. I don't need much more than this to get going through this material realistically. He first brings up the definition, but something really important to matrix here is to understand this fully is
So we will be talking about
he's going to do some fancy
linear
magic on this board
space.
that's not realistic to life as a general
definition.
whole while dealing with this is kind of heavy because it gets into a
X
machine learning problem in a minute.
is
X
a linear space
is a linear space. Could be this space, could be that chalkboard, could be
over
sand, Aristotelian's
field,
model we're figuring out a value for,
which will be
and
represented
that'd be
by
the field,
K.
right? And that field
So
is X. It's
This
also a
field
linear
will
space.
be either the real
And
or
so
the
you get into
complex.
this conservation information
If,
problem, which is really important to
X
understand because he's about to go off
a
on a
set
thing on a product rule, which I can't stand
with
because
two operations.
the first step is way out, and it's not really satisfied by algebra. It's not really
An
satisfied
addition
by geometry
and
because
a
you
multiplication
have to be able to build this
by
geometry.
scalars.
And basically, what they're doing here is hacking that system. And they're saying a K is a scholar field, the students in here that should
So
be able
I'm
to
assuming that there are two
scale by
operations.
multiply,
The addition
multiply by scalars.
will be an
and
operation on X.
it's even times.
which
It's not
will
even like they're a
satisfy
clean multiple.
three
So you get into
conditions.
like, well, I'm going to
So if
multiply
X and Y are elements
all that horse shit.
of X, I will define a new element of X
So
represented by X. We will assume that if I consider
see what he's
the
doing here. He's
multiplication
changing the
by
associative
scalars.
distributive properties by changing
Okay,
the
so
key
two very
in
simple
form
properties.
to here properties. Key is whether you're going to be
Before we
distributive
go on.
or associative. I'm associating
First,
this
I
math
claim
with something,
that
or I'm
if you
distributing
take
this
the
type
element
of
0
math
in your
over a subset, and
field
that is what's
K,
key.
and you multiply
And that key is
0
going
by
to be
X,
what
you
X.
get the element 0 in your
So yes, you get a lot of that. But let me fast forward here a little bit. Get them into heavy bits of. Yeah, here we go.
have a subset y1 and y2 of X.
Okay, so let's get back here. What basically I'm getting at here after he gets past limits and fucking question, he's covering a few tables that are he's covering a few K fields, scholar field, alpha, limitless, what Y is on X, and he's constantly going over this repetition. If, when, then you start to break down this field, which is why what X is actually a fractal, right? Because what we're looking at here is the linear space is an example, or the key of that example, a property of a key, and it's stacking. F1 plus F2 equals minus F1. And basically it turns into linear space again. Now, how we break down that property is the space in which this scholar field is broken down. So there are some key cicada notes in types of terms when you type in linear space to then backtrack through a historical eschatology of these math equations, because this is what the eschatology is any course. So this guy's the devil's mind. It's going to be y1 in a question of first man or any index away from that on a spectrum of Daves in a multi-world circumstance that has a subfield or a sublinear space of it that says I could do a stonemason, but I also have in there the thermaling process, which is a sublinear field, and that has the same algebraic model as you break this down, which eventually this heavy duty stuff doesn't really do. This will give you a good product rule, and there's nothing wrong with this answer, but it's all a limitless infinity on a limitless subfield that always x, y's, and z's pretty easily. So you have to build the geometry first, because the realistic idea is you have to nut and bolt this like no kid in here understands any of this material, and that is the scholar field. Because first I have to separate ones that do understand this material because they have trouble. I gotta get them the hell out of my classroom. But anyways, inside of there, that's that fractal field that says, well, that's all right, actually. This type of math is now a reverse engineering type of functional analysis of its own. I have to analyze what parts of these maths do you understand by the real field, because you're going to be in real physics for what it does. Now defining what the space is isn't against your standard model. It's adjusting your standard model through this, because this is the core syllabus. This is the linear space in which you learn that function, right? So inside of here, now we have to then say, instead of you wanting to throw out any math equation in here, basically we're saying gravity, it has to be under at least some vector position of these ideas, because x equals a point, which is a multiple, right? xy times the degree. So you have to first build this matrix of, well, a point is a vector position, is multiple, it's turned on an axis, it's a minus symbol, turn it again and use some fractals, it's a plus symbol, and it's a multiple symbol, and x is a multiplier. And they kind of give you some feed notes on there, but there's actually a standard model to it. There's actually like, well, in that subgroup, it's plus, multiply, divide, or add, subtract, multiply, divide as a right-hand rule that can be different, not always relative. All things being relative, there is this plus a banana, plus an apple, plus minus an orange in the pot. You never really know given that linear space, but it's going to be pretty freaking specific while you're there. Now, as you're building this product rule, I could say, well, I clocked in and I could do any rock. But let's say I knew the capstone was based on some of the compression of this equation. So it's pretty obvious that, all right, it's a subfield of what that process is, which has a subfield of it, which, I clock in, I burn rock, I start my operation, I fire up the torch, and so that's going to be an XY commutative, X limitless to the first step into what would be here. They're doing another Y for it, or an algebraic Y limitless to 1/2 of the problem. It's going to generalize it in a field theory. They're a landscaper's map or something to that effect. And essentially that landscaper's map is a linear space. It's to say when the time of X, I'm going to follow this happy rabbit trail, no matter what I do, Shangri-La build or otherwise, to a landscaper's map, because it still follows the same damn X. And if I didn't have at least some scalar function of what that is, Taj Mahal or house trailer build blueprints on a business model, then it gets pretty complicated, because some asshole is going to throw omega at you on the limits of the cost of something in here and kick you loose. And realistically, like I said, while he is doing the geometry, it's a far cry from the actual necessary geometry from the Common Core, where we're basically trying to unfuck this monkey somehow by condensing Bohr, De Broglie, you're getting in there to Schrödinger, Rutherford, definitely Gresham and Moore's law going on here for the tech. No doubts about that. It's FMA all day because they X. Moore's law is FMA. Moore's law is Gresham's law on this one will take over this one at some point in time. We don't use the field theory taught by Einstein anymore. We would say a bottom limit of the A set Z operator is general relativity equation. The bottom limit is an elevator moving on a floor, but it doesn't feel like it's moving. That's the observable place. We're all going to go back and do it, use it as the linear field on what it does. And you get into muons and tau and tensor calculus on all kinds of fun, happy horse shit that still... I need a fundamental analysis of something physical. And anytime you do this material next to something that doesn't have something physical, I was just going to go tear down the saw. I was going to say, well, let's cheat the answer of what the multiple is. Let's say to an idea, X equals linear space, saw motor on a tread line, right? And we say that's what alpha is here, and it's going to be mechanic timelines. Anytime I have a form under those ideas, they're maintenance serviceabilities, even if it's how to assemble it. That is a maintenance task on an inversion of changing this over to YX or RKC to CKR, YF over X in the situation, Y equals F over X, and or Y equals X over F. The inversion, where he goes back through here a second ago and he goes, oh, well, we can just cross some shit out because it's in the inversion of the equation, which has to be condensed and collapsed at any rate anyways inside here, because I think it was in here or something like that,
plus
where he goes through here the negative
X.
or the
right, so this
here you go, these cross each other out or something, and it's like, well, why'd you put it in there instead of
the
why do you need the inversion of the negative? Well,
X.
basically was I clocked in without it. And, you know, without it, then I soon had it, that methodology and cut coefficients, but they cancel out each other because what I get is the vector positions of those cut coefficients to give me a record week, or whether I'm up to par on that x. And in this case, he kind of makes it look like an n, but these are actually a mathematical x. Say again, all x's are relative. You got capital form here, which is correlated to linear space numbers and real numbers. It's sets, right? Because they're in Birkendreyer conjecture for what we do, it's a number set. Usually when you see K like that or R, and usually these limitless systems, it's going to be Q by operations to a set of numbers. Let's see if I can find it here. Yeah, here we go. Question 1, question 2, question 3, quantity 1, quantity 2, quantity 3, make it an average, SOHCAHTOA, soak your ass and bleach. You know, when these say this is the limits of what I have to multiply first, it's a limit of, I don't know what that symbol is, could be a muon, could be M, could be, I don't know this, guys. You know, whatever example is going to come into there of whatever stone mill, rocket, Elon shooting, Bezos, Facebook, whatever. And so that became a linear space. That's just an idea, but it's also in general a field theory. It's a volume reduction. It's a way I can say, well, let's engineer a test off of this. I know the answer to all of these things arbitrarily. You have to guess telepathy inside of here. You have negative learning, Pavlovian dogs, fucking being a bit abusive inside here, but Hemingway until the monkey blood bleeds out the book, people. At any rate, inside here, we're going to take this fundamental analysis and take it a bit farther.
To y1 plus y2.
To y1 plus 2 again.
Y1
we'll just take
y2,
it.
right? y1 plus y2.
And realistically, let's look at combatives. How you learn combatives. You can start a fist fight this way, but in training, you're going to start with your feet square in this position. Not because you'll start a fight in this position. Hopefully you do. It's the most proper way to build to the foundation of that thing, minus negative x plus x, and then you reduce those plus x. And so in that gauge, it gives you a better foundation, better momentum of a cleaner trajectory of understanding the circumstances of all these free radiants around here that all play at x. Some LiDAR and self-backing up cars of battery.
x2, so this is x.
All right. Catch you on the next one.